Okay, so you've got cross multiplying. You've been using this strategy, or you've seen this strategy. A lot of teachers use this as almost like a catch-all strategy. Solve equations, cross multiply. Compare fractions, cross multiply. Divide fractions, cross multiply. It just becomes this. Oh, solve proportions, cross multiply. It becomes this kind of catch-all strategy, and students lose track of like when do I cross multiply, and then they just always cross multiply. And what we want to do is talk about in this video comparing fractions and why cross multiplying does work. Like it does work, but we want to get into like, should we be teaching cross multiplying, and like where does it come from? That's what we're going to do here in this video. But I got a tool for you to also catch your eye here and make it easier for you. So here we go. Hey there, Math Moment Makers. John here from Make Math Moments, and in this video we're going to talk about why does cross multiplying work? Where does it come from? Why should we be teaching this? Should we be teaching this strategy? Quick answer is we've got a better strategy, a strategy that connects to previous mathematics. We don't want to teach strategies, tricks that kids have to go memorize and go like, do I use cross multiplying here now? Do I do that like now? So that's what we want to get away from. We want to make sure kids connect ideas to other math concepts. And so we're going to look at that, but I want to let's just start off with looking at where cross multiplying did come from. It is a shortcut. It does work. It does work in lots of situations here. And so we're going to show probably where this shortcut developed, and then show you a better technique. But to help do that, I'm going to bring across a tool that we've been loving here called Mathagon Polypad. Great tool, great free tool for you to use with your students, with your demonstrations. It's a digital manipulative tool, all free for you to use. I'm just over here on Mathagon. I had no need to sign in. I just went to mathagon.org/polypad here, and I can write on the screen. I'm going to do that here first. So let's just make sure we all understand what we're talking about cross multiplying. So like if I got to compare two fractions, and you know what, before we get into that too, it's like this question, like why we're doing a video on here, is actually is a wonder, a question that came from inside our Make Math Moments Academy. One of our math moment makers said that they had been always taught when they teach compare fractions or comparing fractions to show kids cross multiplying, and they weren't sure why they were doing that, but wanted to know at a deeper level and what tasks we can use to help kind of get around that. We're actually going to share a task near the end of this video where you can use that with your students in the classroom as well to kind of help with comparing fractions. Okay, so let's go into what that teacher was talking about here. So let's say I'm looking at 2/3 and 3/4 here, and I'm trying to compare. And one technique here is that what I've heard from teachers and what this teacher was referring to is that they do this butterfly thing, right? Where you cross multiply. You look at here and here and here. They're like, okay, I'm gonna take that 2 and I'm gonna multiply it by 4 and I'm gonna get 8. And then I'm going to take that 3 multiplied by 3, I get 9. Oh, 9 is bigger than 8, so therefore 3/4 is bigger than 2/3. That's that cross multiplying technique that some teachers are teaching their students. But not understand like why that works and like where that comes from and what's actually happening behind the scenes here to make all this work. So I want to kind of just showcase that here a little with you, and then we'll dive into how we can use the tools here to do this a little bit more conceptually for you and your students. It's important to know this kind of stuff. Okay, let me erase all this. Okay. So let's go back here, and if I've got, let's go back here and write 2/3 up here, and we'll do 3/4 over here. And what I'm going to do here is I'm going to use the fraction strips here on the side. Okay, so nice thing about Mathagon Polypad stuff over here is we've got fraction strips, we got algebra tiles if we need them, we've got some really cool, we got a number line that's dynamic. We can use the coordinate system. There's tables. There's dice. There's lots of stuff with numbers and base 10 blocks. Awesome stuff here. So I'm going to go with fractions. I'm going to go to the fraction strip. I'm going to grab the thirds. So this is going to be a whole, and I'm going to drag this to make 2/3. So there's 2/3 right there. And let's make 3/4. And remember, this part of the video here, I'm just going to show where this idea of cross-multiplying may have come from here, and why it does work. We're going to do this mathematically to show like some basic rules about, or basic concepts when we look at scaling things and that nature, to show like this cross multiplication here strategy can work. It's a shortcut though, but we don't want to teach shortcuts. We want to teach understanding. So we're going to show a different strategy afterwards here, after I talk about cross multiplying here. So remember what's happening is they take that 2 and they multiply it by that 4 and they get 8. And they take that 3 and they multiply it by that 3. But what's happening here in the background when that happens, and why, because you're saying, well, it does work. Yeah, it does work. But what's happening here in the background, we got to make sure we know. So what's happening here is actually, first, what's not happening is we're not taking this 2 and multiplying it by this 4 right away. We're actually multiplying this fraction by 3. Like basically, it's like, let's make this side a whole. So, and we're going to compare it to this one, but if we're going to triple, the left side of this fraction to make it whole. We're going to 2/3, and I'm going to triple it to make that like no longer a fraction, right? So I'm going to go 2/3. Well, if I make it 2/3 and 2/3 and 2/3, I'm now going to have all those thirds are going to be gone, and I'm going to have a whole. So it's kind of like I'm going to make that a whole here. Actually, it's going to be more than a whole, but I'm going to basically triple this fraction because it's out of thirds. If I triple it, I'm definitely not going to have parts anymore. I'm going to have wholes. And that's what's happening here. But if I do that here and I'm comparing to this side, I have to actually triple that side as well. So mathematically here, I'm going to actually move these down here. Not mathematically, I mean, but symbolically here is what you would see is on paper, you would say, I'm going to triple this. So I'm going to multiply this by 3, but I have to do that over here as well, just to keep things balanced since we are comparing these two fractions. So we start to muddy the waters here a little bit because this is where this idea of cross multiplying does come from. Okay, so when I triple this, so what I'm going to do is, this is a nice thing about this software here. I'm just going to, all I did was copy, Command C, like copy. You're copying text from a Word document or a Google Doc. You can do the same thing here with these tiles. Okay, so notice I just tripled. I've now got 3 of those. I got to do that over here too, just to keep things a little bit balanced. But I'm going to show you why this actually is somewhat nice right now. So when I triple this, you'll see here that I'm going to redistribute this. Okay, so I'm going to redistribute some of these. So like for example, I'm going to make these holes up here just to simplify some of this stuff. I've got 2. If I fill in this, like take one of these and put it up here and fill that one in, I'll take that one and fill it in there. And so if I use those 2 up, I'm going to fill in this one and this one, and I got 2. Okay, so basically when I multiply that, I triple that fraction, I get 2 out of that, right? So I'm just going to write 2 right here. So there I got a 2 right there. So notice that was the nice thing about tripling that, is that I now have a whole number. And this is where this cross multiplying ends up, why we have whole numbers in the end. Remember, we were comparing 8 to 9. You're going to see that in a sec, why that cross multiplying would work. Keep in mind, remember, we are going to go through a strategy that is going to make a little bit more sense for your kids. But over here, so notice when I do that over here, I tripled this. Let me redistribute here and see what we have. I'm going to do the same thing. I'm going to use 2 of these, and I'm going to fill in 2 of these. 1, 2. So now I have 2 wholes and a quarter. And then you look at these fractions here, and you've got over here 9/4. Right, this ends up being 9/4, which is 2 1/4. Right there. Okay, now here's where again it's going to get a little bit muddier here, but you'll see in the end why we end up comparing 8 to 9 when we cross multiply is that now I'm going to take this fraction and I'm going to quadruple it, so that it doesn't also have, we're not looking at parts here. We're not looking at parts. We're going to quadruple it, and so I'm going to multiply by 4 on this side to eliminate this kind of parts look. So if I multiply this by 4, I'm going to take this. I got to multiply this by 4. So grab all this. 1, 2. Oh man, I gotta see. This is the nice thing about this too. I'm gonna zoom out a little bit. Look at that. That's beautiful. We got 1, 2. I think I got 4 here. 3. And then 1, 2, 3. Yep, we did it. We did it. I got to do the same thing over here. I got to multiply by 4 here too. So there's 2, 3, 4. Okay, so let me just do some redistributing. Oh, let me come back here, up here on paper here. Symbolically, what we did is, right, we multiplied by 4, and this gives us 9. We're going to get 9 out of this. And if I multiply this side by 4, just to keep things balanced, I get 8. Okay, so notice, look at, I should have 8 and 9 right here. This is the representation of 8 and 9. Let me come down to the bottom. Let me show you. I do get 8 and 9 right here. So I'm going to take that one, and I'm going to put it up here. And then I'm going to take that one, and I'm going to put it right there. And I'm going to take that one and I'm going to put it right there. And we should have 9 holes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And over here we have 8 holes. 1, 2, 3, 4, 5, 6, 7, 8. So there we've got, if you look at these holes now, this is where this, remember, this is where this cross multiplying comes into play. Hey, this one, because we tripled it and we quadrupled it, essentially we multiplied it by 12. Hey, 12 common, that does seem interesting, right? 12 being the common denominator. That's what happened right here. Is you tripled it and quadrupled it, and that gave us 9 on this side. This gave us 8 this side. 9 is bigger than 8, and all we did was we scaled up these fractions by multiple of in the end by 12, and we got this. So that we get the same result. But really, remember, when you're cross multiplying, you're taking that one thing, multiplying by 4, take that thing, multiplying by 3. It's a shortcut to doing what we've just done. We're really multiplying both sides by the common denominator, and things will divide out. Let me show you that. I'm going to zoom out and move over a little bit, which is pretty cool, right? Like, that is nifty here on this screen. So if I go back to 2/3 and 3/4, completely symbolically, if I'm multiplying by 12 on both sides, this 3 will divide with the factor of 3 from this, and I'm left with 4, and I end up getting 2 times 4 right there. And when I multiply, this 4 will divide with the 4 factor from 12 here, and left with a 3, and that's 3 times 3 right there. And there we go. That's that same why that trick of cross multiplying works, right? Is because that's what's happening in the background, is you're really multiplying by the common denominator between these two fractions. And what I did was I kind of like stepped through it in extra step way by let's just eliminate let's just eliminate the fraction work here. Let's go right to holes, and then I did it to this side as well. And so when we think of that process, it's natural for teachers to go like, I want to speed that up for my students. I just want to show them the answer, right? That's why a lot of teachers just resort to cross multiplying, but they're not building on the ideas of scaling and equivalence, and doing one side to the other. You got to do it to the other. Important ideas here. Okay, I'm going to erase this. I'm going to start with a new one, and then what we're going to do is we're going to look at the tiles the fraction strips themselves, and I'm going to show you this pretty nifty tool here that can help with a greater way, which is looking at finding that common denominator right off the bat. Okay, so I'm going to go right here. We're going to refresh this. I'm going to write those fractions back up. So I got 2/3, I got 3/4. And if I go back to my fraction strip, now, if you just use fraction strips or have your kids draw pictures or use number lines, you can clearly see right off the bat that 2/3, and you grab 3/4. And there, let me make it 3/4. And if you just compare them right here, boom, you can clearly see that 3/4 is larger than 2/3. So that's a no-brainer right now if you're just using the fraction strips to have your kids solve these problems. But we do want to move towards a symbolic. Now, eventually, this is not like, hey, we got to get there right away. Fraction strips, I would encourage the use of the manipulatives as long as you can. I encourage it even in high school when I teach my high school students. So don't say, hey, we've got to move off manipulatives. It's important to always back things up with the manipulatives. I think it makes things a lot clearer. But here's the nifty part about this is when you think about, okay, if I needed to compare these and I wanted to compare the symbolic representation of these fractions, like which is bigger, then it's basically you want to say like I want to partition these fractions, these representations of these fractions, this visual representation. I want to partition them so that they have the same number of parts, because it's real easy, right? If I look at 6, if I look at 5, 6, there's 5, 6, and I look at 4, 6. Okay, so no, it seems like a no-brainer that 5, 6 is greater than 4, 6, and it's because easily when you look at the symbolic version of those fractions, 5, 6, and 4, 6, since they're both measuring the parts of 6, then this is 5 of those parts and this is 4 of those parts, so therefore that's got to be more. It's a pretty easy concept to think when we, or not easy, I'll just say it's a pretty clear concept when we think when we have the same parts. And that's why we have a real big strong push for finding common denominators. And so when we come back here to these ones, it's like, how can I make these the same parts? Like, so for example, we could say like, I want to partition the thirds into smaller parts. Like I'm not going to go bigger because these ones are actually smaller than these ones. So if I partition them like this, like I get 6. So I partition each of them. Let me go back here. I'm going to cut each of these in half and I'm going to make 6 across. And so when I do that, I now have 4 of those 6. Let me bring back my 2/3 here just to compare, right? So all I did was cut my thirds in half to create 6, which is more parts. But you know, this one's fourths, so I kind of missed that right there. So it's like I could do that to over here too. I go, I got to partition that one into 8s. Those aren't matching up right now. So let me go back. Let me go back to fourths. Let me go back to thirds. It's okay. So maybe I could cut these in not halves, but thirds. 1, 2. Like if I go thirds, what's that? 1, 2. So now I have ninths, right? So I could go ninths. Okay. Well, let me do this one. Let me go. I could go 8s, right? We're getting close. Oh, that's gonna be 12ths. That's if I cut them into 3. This one thirds. Let me go back to this one again. Let me go back to the thirds. Okay. Well, if I cut this into fourths, right? So if I keep partitioning there, I got 12ths. Oh, wait, I saw 12ths back here. Hey, I can go this one into 12ths as well. Therefore, since I can partition each of these into 12ths, I can now go, well, how many 12ths are in each one? Look at this. There are 1, 2, 3, 4, 5, 6, 7, 8 12ths in the 2/3. And 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths in the 3/4. Hey, we're really comparing the 8 and the 9 again, right? Like that's the same thing. And so when we are looking at partitioning, that's what's happening right here. We're partitioning this, splitting this fraction up into smaller pieces, and then we can compare the pieces as long as we have the same. So the strategy here, instead of cross multiplying, is look for those common denominators. Teach common denominators as that method, and you stay with the visual representation here before you just go straight to symbolic and go, let's find the lowest common multiple between 3 and 4 and list them. Work with the fraction strips. Try to figure out like, how can I take my 2/3 and change it out so that I have equivalent fractions that also give me 2/3 but are in different parts, and when can I have those parts overlap with the other one, right? So you can continually switch them out like I was doing, and that's the beautiful thing about this software. Really nice way to split that up, and all I was using was some of the features down here to split these up into smaller parts and keep the actual fraction equivalent. So love that feature from Mathagon here. So in recap here, we are looking at comparing fractions. A lot of people are teaching cross multiplying, which is a trick people have to memorize. And there's so many versions of this cross multiplying floating around when to use it. Remember, it becomes this like catch-all strategy. Hey, if you're going to compare fractions, let's go back to the basics. Let's look at finding those common denominators. Let's look at using our manipulatives. Stick with that. Avoid the cross multiplying these if you can. I think it's just going to muddy the waters deeply. Now, if you're looking for a task here or a lesson that can help you with some of the ordering of fractions, because we would encourage that this ideas and these strategies and these practice to come out while we're working with tasks, head on over to makemathmoments.com/tasks. And on our tasks page, let me go show you here the tasks page. Here we go, units and tasks. Let me just quickly show you here. Tasks page, we have tons of tasks here ready for you to use, free. Teacher guides are for Academy members. But if I find fractions here and it narrows down my fractions work. Now, if I go to Woolly Worm's race, that's my comparing fractions. That's our comparing fractions lesson. Coming in here, and if I'm going to go to the guide tab, and the guide tab tells you right here in intentionality, it'll tell you all about where we are looking for. And then there's partitioning here. There's comparing here. There's some videos here to spark some curiosity. We've got full walkthroughs of what you should be doing as a teacher to help your kids connect their strategies to the learning goal, which is going to be some comparing fractions here, and you can see the end. I'm going to skip down to the some student solutions here. You can see some comparing of fractions here. Basically, there's a race between these worms that are from a fair, and you point the water and they go up faster. So there's this task that's built around that. But what we have is some fraction comparing to do to see who wins the race. This student uses fraction strips. This student uses a number line. And so we can consolidate some strategies together. We give you all of the thinking around here. So when you do a task like this, the teacher guide will not only give you the resources to run that task, but teaches you the math behind the task, which is really important here. So if I kind of skip through this task, you'll see some of the comparisons in this task in the consolidation stage, and you get to download these resources as members of the Academy. So that's what's happening here over on makemathmoments.com/tasks. But remember that question did come from our community member about like, hey, I have to teach cross multiplication here when comparing fractions. Hey, let's try to limit that. Let's go and use the building blocks of where some of our strategies come from. It's important to ask yourself those questions, right? Like, if I don't understand why the strategy works, I have to dig deep and then go, where does this connect with what we've learned in the past or what my students have learned in the past? So hey, if you want access to the Academy, you can get it 30 days for free, and you get all the tasks, all the teacher resource guides, plus our courses. We have lots of courses there. Most recent one is our assessment course, a 7-module course on assessment in your math classroom. So you can get first 30 days free. The link is down in the description, and we're looking forward to seeing you next time. Don't forget to subscribe here so that you get all the videos when they come out. Take care and have a great week.